Hello, this is Mr. Win, and this video is about solving logarithmic equations. So in this video, we'll finally start solving them. Usually first have to use the three properties to combine or simplify our problem. After that, we can use our converting technique, and then finally we use our normal solving methods. For example, if it's linear, get x by itself. If it's quadratic, equal to 0, and then quadratic formula or factor. One important thing to keep in mind is that you can only take the log of positive things. If you try to take the log of 0 or a negative number, we get an error. So let me show you in the calculator fast. If I log any positive number, any base, for example, log base 10 because it's easy of 6, I get an answer. That's fine. I can also log a decimal. Log base 10 of 0.2 is an answer. It's negative, but that's okay. If I try to log base 10 of 0, I get an error. I try to log base anything, but in this case, base 10 of, say, negative 8, I got an error, non-real. Alright, so you must log positive numbers. Cannot be 0 or negative. Because of that, we have to check our answers for extraneous solutions. So let's try the first problem. Log base 4 of x plus log base 4 of x minus 6 equals 2. We cannot use our converting technique yet because this is not one term on the left side, it's two terms. Luckily, we have the product property that states if you're adding multiple logs with the same base, in this case base 4 and base 4, you can combine to a single log base 4. And just multiply the inside. So it'll be x times x minus 6. Now that it's one term, you can use your converting technique, however you do your BPN thing. Remember, we're trying to get rid of the word log. We have to exponentiate both sides. These are now exponents, they need the correct base. The base will match this base. So I'm going to do base 4 on both sides. So it'll be 4 to the exponent, log base 4 of, and I distributed x squared minus 6x. And don't forget to have the base 4 on this right side as well. So it'll be 4 to the second power. Alright, 4 to the exponent log base 4 cancels out. And the right side is just 4 squared. So what's left would be x squared minus 6x equals 4 squared. And you have a number to an exponent, make sure you fix that. So x squared minus 6x equals 16. Notice it's quadratic. If it's quadratic, you have to equal to 0. Once you equal to 0, you can solve it however you want. Quadratic formula or factoring. I'm going to factor by using guess and check. So I get x minus 8, x plus 2. I do the 0 product property by setting those both equal to 0. So my first answer will be positive 8. My second answer will be negative 2. Now before I box those in, because I could stop and get it wrong, you have to check. Plug them into the original problem, see if it's going to be a log of a negative number or 0. Because if it is, you cross it out. So I plug in the first one, 8, in the original problem. I get log base 4 of 8 plus log base 4 of 8 minus 6 equals 2. Well, the first one's positive, we're good. I don't need the decimal, I just need to make sure the inside is positive. Then here, 8 minus 6 is 2. I can log base anything of 2, that's fine, that's good. So that one's good. So 8 is one of our correct answers. I'll try negative 2. If I plug in negative 2, well, the first one's right and negative inside, so that fails. The moment you have log of a negative number, you can stop and just cross it out, but I'm going to do the other one as well. So inside here will be negative 2 minus 6 is negative 8. I cannot log base anything of negative 8, so that fails. So this one does not work. So my final answer is just x equals 8, not negative 2. Next problem. Solve ln of 24 minus ln of x plus 1 equals ln of 8. So again, I can't do any converting tricks right now because there's multiple terms here. But like when we combine this, when you have ln minus ln, the quotient property states if you subtract multiple logs of the same base, then these are both base e, you just make it a single log or ln. And divide the inside, so it'll be 24 over x plus 1. Alright, now it's one term. You do your converting technique. Because we have the log, we have to get rid of the word log, we have to exponentiate. These sides are now exponents. The correct base will be e. So it'll be e to the exponent ln of that fraction equals e to the exponent ln of 8. Remember, e to the ln cancels out, so you get that. E to the ln cancels out, so you get that. So all we have now is 24 over x plus 1 equals 8. We solve this as a fraction, get rid of fraction, multiply by denominator both sides. Well, the denominator crosses on the left side, this is 24 on the right side, you're going to have to distribute. But once I distribute, I get 24 equals 8x plus 8. This is linear, you do not have to equal to 0, although you could. I'm just going to get x by itself, so I'll subtract 8 both sides. Then I divide by 8, I get x equals 2. Before I box that in, I have to check, plug into the original problem, make sure it's not negative or 0 for any of the logs, including ln. So I plugged in. The first one's ln 24. You can log any base of 24. That's good. This one be ln of 2 plus 1, 3. You can ln 3. That's good. And in this one as well, it's positive, so we're good. So this answer does work out. So the answer is x equals 2. All right, last problem. Solve 2 times log base 9 of x plus log base 9 of 2 equals log base 9 of 32. So again, too many terms. Now here's one thing. When you use the product or quotient property, so when you're adding multiple logs or subtracting multiple logs, you can only combine them to single log if there's no number in front. So this 2 is in the way. So here we actually have used the other property, the power property, to bring this 2 back as an exponent. So log base 9 of x squared is the same as the first thing. I leave the second one alone, nothing changed. Leave the one alone, nothing changed. Now I have log base 9 plus log base 9 with no multiply in front. So if it's log plus log, same base, you make it a single log, keep the base same, multiply the inside, so x squared times 2, and on the right side is nothing to do. Now it's one term. I can exponentiate by picking the correct base. I'm going to do base 9 both sides. So base 9 to the exponent of log base 9 of this 9 multiplied inside, 2x squared, equals 9 to the exponent log base 9 of 32. 9 to the exponent log 9 cancels out. It's just 2x squared. Again, 9 to the exponent log base 9 cancels out. It's just 32. So our final equation will be 2x squared equals 32. This is quadratic. A lot of ways to solve it, but I'm going to equal it to 0. Then instead of quadratic formula, I'm going to factor. GCF is 2. What's left will be x squared minus 16. Well, that's factorable as a difference of squares. So that's going to be x plus 4, x minus 4. Then I do the 0 product property. You ignore the 2, there's no letter, but first answer is negative 4. Second answer is positive 4. Before I box it in, you have to check. Make sure you don't log a negative or 0. If I plug in negative 4, here's what I get. The first log is already negative. I cannot do that, so it fails. The second log is positive, that's okay. Third log is positive, that's okay. But one fail means that answer fails. We cannot use negative 4. I try the next one. I get that. I can log base ending of 4, that's good. I can log a positive, that's good. I can log a positive, that's good. So this answer does work. The final answer here is just x equals 4. Hope you enjoyed the video. Make sure you ask your teacher any questions. Thanks for watching. Bye.